In college algebra, we talk about a lot of different types of functions. One of the functions we'll be using is an absolute value function. So in this video, we'll build the base graph of an absolute value function so that in future videos, we can look at transformations of that base graph as well as solving. What I mean by a base graph is kind of the most fundamental graph of an absolute value function. Whereas in the future, we may move that graph left, right, up, down, and that sort of thing. So the most basic absolute value function would just be f of x equals the absolute value of x. And we denote absolute value typically with these vertical bars. So you've likely seen the absolute value bars before. Basically, we can think about the absolute value as making the output always positive. So for example, the absolute value of positive 7 is 7, whereas the absolute value of negative 7 would also be 7 because both of these numbers, 7 and negative 7, can be thought of as having a distance of 7 from 0. So another way to think about absolute value is like its distance from 0. So to build the base graph, let's use a technique that we've used a lot in the past, and that is just a table of values. So we'll pick some x's, we'll choose the x as the independent variable, and then we'll find y by just taking the absolute value of those choices. So it would be good to choose some negatives, 0, and some positives. Just because of my space here, I'll choose 5 values. This should be enough for us to get a feel for the base graph of this function. So based on these selections, these choices for x, the absolute value of these values will produce the y value. So the absolute value of negative 2 is just 2. Again, you can think about the distance between negative 2 and 0 is 2 units, distance being always positive. The absolute value of negative 1 is 1. 0 is 0 units away from 0. And then when you have the absolute value of a positive, it's just that same number. So by creating this XY table, we really have 5 ordered pairs that we can plot and hopefully get a good feel for the graph of this function. Just so it's clear, the ordered pairs that we'll be plotting will be negative 2, comma 2, negative 1, comma 1, 0, 0, 1, 1, and 2, 2. So those come from just taking our x, comma, y pairs. So let's make some space to plot these 5 points. And let's see, I need my x's to go as far to the left as negative 2, as far to the right as positive 2. And then in the y direction, we really are only going to have positive outputs, you can tell. Cool, so let's plot those 5 points. When x is negative 2, y is positive 2, so right around there. When x is negative 1, y is positive 1. When x is 0, y is also 0. And then x being 1 corresponds to y being 1. X being 2 corresponds to y being 2. So as I plot those 5 points and we think about connecting them, hopefully it seems pretty intuitive from my sketch here that it looks like the graph is actually just like a V. So it comes very sharply to the origin with a linear equation and then does the same thing but with a positive slope on the other side. So what we have shown in green now is the base graph of the absolute value function. And what we'll do in future videos is explore a little bit what it looks like to move that graph left, right, up, and down. So knowledge of the base graph is so important because you can always take the base graph and then use that to build transformations.